In this video, we're going to learn about horizontal and vertical stretches. For our first problem, we're given the point 2, 2, and we want to plot the image of the point after the following transformations. The first transformation we'll consider is a stretch with stretch factor 3 and invariant x-axis. The invariant axis tells us which coordinate doesn't change in our point at all. So since the invariant axis is the x-axis, we don't change the x-coordinate at all. We just stretch up or down in the y direction, so this point will be moving up or down. And the extent to which we move up or down depends on this stretch factor here. Since we're not changing the x-axis, the stretch factor is going to be the thing that only multiplies the y-coordinate. So this first transformation will transform that point 2, 2 into another point whose y-coordinate is multiplied by 3. So 2, 2 goes to 2 and then 2 times 3, which is really just 2, 6. Let's plot that point. 2, then 2, 3, 4, 5, 6. It goes up here. Intuitively, the new point is 3 times as far from the x-axis. The original point was only 2 units up, whereas the new point is 6 units up, 3 times the distance. Okay, on to the second transformation, a stretch with stretch factor 0.5 and invariant y-axis. Okay, so invariant y-axis, this means the y-coordinate is not changing this time. So it's the x-coordinate that the stretch factor is being applied to. So let's go ahead and figure that over here. So that goes from 2, 2, and then the new point, we multiply the x-coordinate by 0.5, so 2 times 0.5, and then the y-coordinate stays the same at 2, and that point is, well, 2 times 0.5 is just 1, so 1, 2. So the new point is over here, 1, 2. Let's label it right there. And intuitively, since the stretch factor is 0.5 and the y-axis is invariant, the distance from the y-axis is just getting halved. It moves halfway closer to the y-axis. Now for the third transformation. A stretch with stretch factor 1/4 in the x direction and -4 in the y direction. So let's go ahead and apply this to our point. Our point is 2, 2. And then after this transformation, the x-coordinate is getting multiplied by 1/4. So 1/4 times 2. And the y-coordinate is getting multiplied by -4. So -4 times 2. Now let's simplify this point. So 1/4 times 2, that's 2/4, which can be simplified to just 1/2. And then -4 times 2 is -8. So our new point is 1/2 -8. Let's go find this point. So go over 1/2 and then down 1, 2, 3, 4, 5, 6, 7, 8 to -8. So there's our point, 1/2 -8. Let's check this intuition also. So stretch factor 1/4 in the x direction, that means the distance in the x direction should now be 1/4 of what it initially was. And it was initially 2, now it's moved closer to the y-axis, it's moved in the x direction to 1/2, which is 1/4 of the original distance of 2. And -4 in the y direction. So negative really means it's flipping over the x-axis. So the -4 means that the distance in the y direction should be 4 times the original distance, but going the opposite way. So originally it was 2 up, now we're going 8 down. So yeah, that makes sense also. Next question. The segment A'B' right here is an image of the segment AB over here under a stretch that takes each point xy and moves it to ax, by. That stretch is in the x and y directions. So what are the stretch factors a and b in the x and y directions? Why don't we write down this transformation once again but color-coded. So xy, those are referring to the original points. The original points are on the segment AB, so let's put those in blue to match it up. So x, y, the original points, these get transformed into the new points, which are on the segment A'B'. So let's put that in red. Ax, by. Why don't we write down this transformation for the particular points A and B? So for the point A, well, what is the point A? A is -1 and then down 1, 2, 3. So A is -1, -3. So -1, -3 gets transformed into the point A times -1, so just -A, and then B times Y, which is just -3B. So this is the point A here, and this point needs to be A prime, because that's A after the transformation. And we can pick out what A prime is from the graph here. A prime is just -2, +1, prime -2, +1. So we know that this point here has to be equal to -2, +1, because that's also A prime. And from this equality, we can pick out two equations by setting the components equal to each other. So the first component, the x component of each of these points, has to be equal. So we have that -A equals -2, and likewise the second components, the y components, have to be equal. So -3b has to equal 1. So -3b equals 1, and now we can solve for a and b. So if -a equals -2, just multiply both sides by -1, and then we get that a equals 2. If -3b equals 1, then just divide both sides by -3. I'll cancel out that -3, and we just get b equals 1 divided by -3, which is just -1/3. So there are our stretch factors in the x and y directions. A is 2, b is -1/3. Notice that we could have just as easily used the point B. If we had started with the point B, let's find out what that is. That's 2 and then down 1, 2, 3, 4, 5, 6. So 2, -6. If we had started with that point 2, -6, which is B, and applied the transformation, the resulting point would have been A times the x coordinate, so 2A, and then B times the y coordinate, so -6b. And that would match up with B prime. And then we could just pick out B prime from the graph. It's over 1, 2, 3, 4, and up 1, 2. So that has to be equal to 4, 2. That's also B prime. So the x components have to be equal. 2a has to equal 4, and the y components have to be equal. -6b equals 2. And we could solve both of these equations. 2a equals 4, just divide both sides by 2, and that cancels out this 2 in front of the a. We get a equals 4 divided by 2, which is 2. And then we can do a similar thing for b, just divide by that -6 on both sides. That'll cancel out the -6, and we'll just have b equals -2/6, which can be simplified to b equals 1/3. So either way, we still get a equals 2 and b equals -1/3. So it really doesn't matter what point you choose. You could choose any point, and the stretch factors should come out to be the same, because the whole segment is being stretched by the same stretch factors. Alright, so final answer is a equals 2, b equals -1/3. Final question. The triangle ABC is transformed into the triangle A prime B prime C prime through horizontal and/or vertical stretches. However, only B prime is known. Draw the rest of the triangle A prime B prime C prime. Okay, so here's the idea. We know the points in the original triangle, and we know one of the points in the new triangle. So based on that, we can figure out what the transformation is that takes this old triangle to this new triangle. In particular, we can just look at the point B to B prime. It's kind of like the previous problem. Let's set up our transformation. So our transformation takes old points x, y, and brings them to new points of the form ax, by, where a and b are the stretch factors in the x and y directions, respectively. So this transformation brings b to b prime. So why don't we plug in b and b prime into here and figure out what a and b are. Alright, so first of all, what is the point b? B is over 1, up 1, 2, 3. So b is the point 1, 3. So this transformation takes that point 1, 3, which is B, and transforms that into the point A times 1, so just A, and then B times 3, so just 3B. So if the stretch factors are A and B, then the point B prime needs to take this form A, 3B. But we're given B prime on the graph too. What is B prime on the graph? Well, that's over 1, 2, 3, 4, and up 1, 2, 3. So B prime is 4, 3. So this point A, 3B, that's B prime, but we also know that B prime is given by just 4, 3. That's also B prime. Now with that, we can set the x-coordinates equal to each other. So A equals 4. Well, that was easy. Now we know what A is, and we can also set the y-coordinates equal to 3B equals 3. And to solve that, we can just divide both sides by 3. Cancel out that 3 in front of the b, and we get b equals 3 divided by 3, which is 1. So our transformation is really just x, y is transformed into ax, but a is just 4, so this is 4x, and then by, b is 1, so just y. In other words, this is a stretch with stretch factor 4 and invariant y-axis, because the y-coordinate doesn't change at all. So really these points A, B, and C are being stretched by a factor of 4 in the x direction. So let's figure out what the other points are. A, that point is 1, 0, and applying this rule, the point A, which is 1, 0, gets mapped to the new point A prime, which is given by 4 times the original x, so 4 times 1, and then the original y, so 0. So simplifying, A prime is just 4, 0. So let's plot that. A prime is 4, 0. 1, 2, 3, 4, right over here. Okay, and let's do the same thing for C. So C is originally 1, 2, 2, 0, and we just plug that into our transformation. C, the point 2, 0, is mapped to the point C prime, which is 4 times the original x-coordinate, so 4 times 2, and then the same y-coordinate, 0. And that simplifies to 4 times 2 is 8, and then 0. So C prime is 8, 0. So that's 4, 5, 6, 7, 8. There's the point 8, 0. So C prime, 8, 0. Now we've got all of our points in the triangle and we can just connect them up. So let's do that. So A prime to B prime, then B prime to C prime, and then C prime back to A prime. So there we go. There's our triangle ABC. Now we know how to work with horizontal and vertical stretches in addition to a whole bunch of other transformations. In the future, we'll practice combining many of these transformations at once.